Hi everybody, I'm Professor Rad, and in this video we are going to use a z-score in order to find a confidence interval. So this is a situation when the population standard deviation is known. Let's go ahead and read through this problem, and as I read through I'm going to highlight some information that seems important. So let's begin. It says, suppose a simple random sample of 85 students who took the SAT have a mean math score of 511. Now, from previous experience, it is known that sigma is 110. We're going to construct a 99% confidence interval. Then it says round all interim values to the nearest thousandth, and round your final answers to the nearest whole amount. Okay, so let's deal with that first. Interim answers, those are going to be sort of values you find in the middle of solving. So that could be like your critical value. It could be a standard error. It could be a margin of error. Okay, so we're going to round all of those to the nearest thousandth. Our final answers, that's going to be our confidence interval in the end. We're going to round those values to the nearest whole number. All right, so let's go ahead and fill in some of this information based off of what we highlighted or circled here. So our confidence level, that's the percentage that's given to you. So that's our 99% level of confidence. Your point estimate is going to be your sample mean. So when you see point estimate, you want to remember that that's going to be X bar. And that was our mean here of 511. Now, you do want to make sure that you label your point estimate. In this case, these are scores, so they don't really have any label to them. If you wanted to, you could say this is 511 points. But just know that you want to be on the lookout for labeling your values. For our standard deviation, sometimes you might know sigma and other times you might know S. So for our standard deviation, in this case they told us sigma. So I'm going to say sigma is 110 points. Now, because we know sigma, that means this is a z-score problem. If it said S was 110 points, then that would mean that this would be a t-score problem. All right, and we have pretty much summarized most of the information that we were given. The only piece of information we didn't summarize yet is what I had highlighted in yellow, this SRS of 85 students. So off on the side, they didn't ask me for the sample size, but I'm going to put that here. N is 85 students. All right, and so that's sort of the first wave of this question, reading through it and summarizing the information we had, as well as determining the type of question. Now, when I go to solve it, for critical value, that means exactly what we identified here. Our problem type was a z-score, so our critical value will be a z-score. Z-scores are the easy ones where you just use the very bottom of the table and your confidence level. So we need to find a z-score for 99% confidence interval. So I'm going to bring my table over here. For 99%, our z-score is going to be 2.576. And remember, you look at the confidence level, and directly above it is going to be your z-score. So 2.576. Just as with our normal curve questions, z-scores never get labeled, so we're going to keep this as 2.576. All right, next we need to determine our margin of error. The symbol for margin of error is going to be E. And since this is a z-score problem, our formula is z times sigma over the square root of n. So we're going to take our z-score of 2.576 times sigma, which we said was 110 points, and divide by the square root of n, which we determined to be 85. Let's bring our calculator in here. So we're going to do 2.576 times 110, and then we'll divide by the square root of 85. Okay, now here's a situation where we're getting a very long decimal. So up at the top, this is an interim value because we haven't found our final confidence level or interval yet. So our interim value to the nearest thousandth. So 10th, 100th, 1000th. So the 7 is going to bump that 4 up to a 5. So we're going to get 30.735. And E is labeled just the same as X bar and sigma, so this will be points. All right, next, for our interval, this is like our final answer, we're going to take X bar minus E and X bar plus E. You want these numbers to be in order from smallest to largest, so we'll always do the subtracting first and then the adding second. We determined that X bar was 511, so we'll do 511 minus and 511 plus. And then our margin of error was 30.735. All right, so then we can go ahead and find those values. So 511 minus 30.735 is going to give us 480.265. So rounding to the nearest whole number, that 2 means that 0 stays the same. So we're going to get 480 points. And then we repeat this just by adding. And this time that 7 is going to cause that 1 to go up to a 2. So we get 542 points. So these scores were about math scores for the SAT. So we are 99% confident that students are going to score on average between 480 and 542 on the math portion of the SAT. So formally, let's summarize this. I can conclude with 99% confidence, since that was our confidence level, that this is about math scores on the SAT, so that the mean math SAT score is between 480 points and 542 points. This means that the probability that the interval of 480 points to 542 points contains the true mean math SAT score is, since we use 99%, 0.99. So I can conclude with 99% confidence that the mean math SAT score is between 480 and 542. What this means is that the probability that the interval that we found of 480 to 542, the probability that that interval contains the mean is 0.99. All right, that's going to wrap it up for this video, how you can use a z-score to find a confidence interval. In the next video, we will use a t-score to find a confidence interval. I hope you have a great day, and I'll see you next time.